Hi, this is Stuart Bruce from Washington College. I'm going to give a short lecture on establishing your 3D world. So far, you've learned how to use some of the basics of ArcScene. With this particular lesson, we're going to do a more complicated lesson to really utilize some of the tools for a more comprehensive 3D visualization of the town of St. Michael's. There's a lot of applications for 3D and GIS, the entire gamut. A lot of times it's really used for planning so people can kind of understand the visual nature and really have a better feeling for the geography of a place. So we're going to continue our exploration of ArcScene. Some warnings about ArcScene, though, definitely requires significant computer resources. You need a fair amount of memory, and you have to have a decent video card. If you're working on an older computer, kind of a cheap computer, ArcScene may not work very well. So it's not a good idea at all. And then, as always, with any ArcGIS product, you want to make sure that you save frequently in case your document crashes right in the middle of doing something. So some of the layers that we're going to use to visualize St. Michael's, obviously we're going to use our buildings again. We're going to extrude them. We're going to add some street furniture, trees and cars. We really could do a lot more, but it would have made the lesson very, very long. So I think just using trees and cars is enough to give the idea on how to do that. First, we're going to talk about aerial imagery. Depending on the scale of your scene, in the case of St. Michael's, we're in pretty close, so we only use high resolution imagery. But if you're trying to do a big city like Baltimore, you don't want to use high resolution imagery. It's just going to slow the animation down. We tend to want to use either compressed imagery such as Mr. SID or ECW, which is enhanced compression wavelet imagery. Basically, these file formats work better than a full-scale GeoTIFF or something like that. Also, want to make sure that you think about your scene and what you're actually going to show in your final visualization and animation, and don't add a bunch of stuff to the scene that's not going to be viewed. Now, in the previous, or actually in this lesson, you're going to learn about quality enhancements for imagery. So under the Rendering tab and Layer Properties, there's a slider down here called Quality Enhancement for Raster Images. The Esri default is to put it just a little bit over the middle. It makes the images a little fuzzy at times, and what we want to do is try to crank that up. We don't always go to the full high resolution, but maybe one notch down from that, and you'll see the difference in Module B lab exercise. If you bring in a bunch of individual images versus a mosaic image, you're going to want to take those images and actually put them into a group layer. This allows you to turn off the images all at one time instead of one little tiled image, which can be very kind of a pain in the butt, to be honest with you. Now for building outlines, which is a pretty fundamental layer to have in any 3D visualization, most counties today will have building outlines that you can use, but if you don't have them, you'll have to digitize them yourself. And you want to make sure that you have nice sort of rectangles or squares for your buildings, not this kind of sort of sloppy looking thing, because when you extrude it, it's really going to look poor. If you have some attributes for the height, that's great. But if you don't, you can kind of standardize a single level height. Now, as we learned in a previous exercise, you can basically do an extrusion to add some, basically the third dimension. If you have a height field, you can go ahead and use the expression builder to take that height and then modify it. Kind of gives you some variety, makes the scene look a little bit more realistic. Of course, you're going to want to try to use Symbology to add some sort of variety. Instead of all the same color, you can kind of spice it up a little bit. ArcScene does have the ability to bring in Google SketchUp buildings. We're going to try to play with that in a later lesson. I will warn you, though, that ArcScene has some capabilities based on your video card capabilities that you're probably unlikely to bring in like hundreds and hundreds of SketchUp buildings unless you make sure that they are well constructed and have a very good design in terms of the number of faces and things like that. It will actually crash ArcScene. It's kind of peculiar if it ever happens to you. So when you're trying to add things like trees and cars, you may or may not have these data layers, so you may have to create them, and you may have to create some attribute codes so that you can have some variety. You don't want to really have like the same tree throughout the entire scene or the same car throughout the entire scene. So in the case of trees, for the St. Michael's project, we went out and basically put dots on the trees from the aerial photographs. In theory, you could go out and GPS every tree, but you're probably not going to have the time to do that. By adding a kind of random code to the trees, you can sort of have some variety in the trees. It looks a little bit more realistic to have multiple tree types. Esri gives you a great sort of symbol set for trees that you can use. You can also modify the color, give it a little variety in the color, and you can change the size of the tree. You know, if you're doing a 3D visualization of a brand new development, the trees are all going to be small. But if you're going to do a 3D visualization of established neighborhood, the trees are going to be bigger. And that's just some flexibility that you have with ArcScene. Cars are a little bit more challenging because basically the cars could be pointing in different directions, and you can see the cars on the air photo. So you really have to try to match up the car angle with the actual aerial photograph. So what we did in the case of St. Michael's, we basically went and we picked 4 different directions to try to align them. Uh, the symbol library in ArcGIS gives you 24 cars to work with, so you could have basically 96 different symbols. What we did is we just used 4 different directions and we had 6 different codes. So 6 times 4 is 24. And that's what you have a chance to work with in the module exercise. You can add other street furniture. Esri has symbol sets for everything from fire hydrants to light posts to park benches. We're not going to do that in the lab exercise just for time purposes. But if you wanted to play with that, you know, you would have to create a new feature class, attribute it for what you want the symbol to be, and you could add a lot of realism to the scene. Now, in the Introduction to 3D Analyst course that we have here, there is a comprehensive 3D Analyst project where you're going to create your own 3D world. This particular lesson is kind of showing you some of the basics you might want to do, but you should start thinking about now what you want to do your own 3D world for the course assignment. If you look in the Moodle under Geo Workshop at the very end, there are some guidelines for the project. I might tweak those a little bit, but I suggest you take a look and start thinking now about collecting the data sets that you need to build your own 3D world at the end of the course. Thank you, and I hope you enjoy these lessons.